Let us continue resonance, in which we will take ozone molecule. We will take ozone molecule. This ozone molecule, for this we will write a Lewis dot structure. Lewis dot structure will write ozone, 3 oxygen atoms are there. Then oxygen valence shell is having 6 electrons. Oxygen valence shell is having 6 electrons. This oxygen valence shell, each oxygen valence shell is having 6 electrons. Therefore, we will write 6 dots. Next, we will give bonds. Here we are giving double bond. Here we are giving dative bond. This dative bond we are writing as a normal covalent bond. Before that, this oxygen hybridization is what we will see. It is having one sigma bond here, one sigma bond here, totally 2 sigma bonds, one lone pair. So 2 sigma bonds and one lone pair. 2 sigma bonds and one lone pair in the sense sp2 hybridization. Therefore, this lone pair present in which orbital in the sense sp2 hybrid orbital. Okay. Then we will write this dative bond as normal covalent bond by giving formal charges. This double bond we will give. This double bond we are giving as it is. This dative bond we will write it as normal covalent bond. This lone pair we will write. Now this oxygen is a donor. For donor +1 we will give. For this acceptor, for acceptor we will give -1 is the formal charge. Sorry. It is a, this is called what in the sense a Lewis dot structure we can say. Sir, while writing this Lewis dot structure, can we write this dative bond on left side and double bond on right side? Yes, we can write this dative bond on a left side and double bond on right side. Then why to write? What is the necessity? Sir. Now we will see experimental fact. We will see what does experimental fact says, that we will see. Experimental fact says that in ozone, bond length of OO. It is not single bond length between OO. That's all. Okay, single bond or what we have to know later. Bond length of OO in ozone is how much in the sense 128 picometer. 128 picometer. It is experimental evidence says. Experiment says that bond length of OO is 128 picometer. That is only one value. That is only one value. So only one value in the sense, left side bond and right side bond should have same nature. Left side bond and right side bond should have same nature. Then only we can say this bond length and this bond length remain same. The experiment says that bond length in ozone is only one value, that is 128 picometer. Only one value in the sense left side bond and right side bond should have same nature, then only one value possible. Then only this side bond length and this side bond length will be equal. Left side bond length and right side bond length will be equal when in the sense if the nature of this bond and this bond will be same. Sir. But how it is there? We have written Lewis dot structure. This Lewis dot structure says left side double bond, right side single bond. Sir. If double bond in the sense, what is the bond length? Particularly double bond means what is the bond length, that we will see. Double bond means 121 picometer. This we have written not from experiment of ozone. Double bond means 121 picometer. That is the meaning. Single bond means 148 picometer. Single bond means bond length is 148 picometer. Here we have written 148 picometer. This is not from experiment of bond length of ozone. This 148 we have written, which is not from the experimental bond length of ozone. Then how do we know 148? For example, I am taking hydrogen peroxide. In the hydrogen peroxide, if you see, The hydrogen peroxide structure is like this. Here O single bond O is there. That bond length we have written here. Then this 121 from where we have written in the sense O double bond O, ozone oxygen molecule is having double bond. That bond length we have written here. This is not from experiment of ozone. Experiment bond length of ozone. Okay, experiment bond length of ozone says that bond length is 128 picometer. Experiment says this one. Sorry. So here this indicates that this double bond length and single bond length we have written 121 here, 148 here. Sorry. Double bond for that bond length is less. Single bond means for that bond length is high. Why is it so? Why single bond is having lesser bond? Single bond is having higher bond length. Double bond is having lesser bond length. That we will see. Now we will take a hydrogen peroxide. Hydrogen peroxide is having like this. This bond contains two electrons. This bond contains how many electrons? Means two electrons. Now we will take this oxygen nucleus. Oxygen nucleus we will take. This oxygen nucleus we will take, and these two electrons involved in bonding. These two electrons involved in bonding here. Now this nucleus of this oxygen is attracting this bonding two electrons. Nucleus of this oxygen is attracting bonding these two electrons. Simultaneously, the bonding two electrons attracting this nucleus of oxygen and this nucleus of oxygen. Therefore, here due to attraction, bond is formed. Overlapping takes place. Therefore, bond is formed. Now we will take a O2. We will take O double bond O. This oxygen nucleus we will take. This oxygen nucleus we have considered. This oxygen nucleus we will consider. Here the bond contains how many electrons? In the sense 4 electrons. That 4 electrons will write. This nucleus is attracting these 4 electrons. This nucleus also attracting these 4 electrons. These 4 electrons attracting this nucleus, and these 4 electrons attracting this nucleus. So due to attraction between these two oxygen atoms, overlapping takes place. Due to overlap, double bond is produced. Now see, here nucleus and here nucleus remains same. Here nucleus and here nucleus remains same. But bonding electrons are different. Here single bond, 2 electrons. Here double bond, 4 electrons. Therefore, here we can see magnitude of attraction. Here how the magnitude of attraction will be there and how the magnitude of attraction will be there. Here if you see magnitude of attraction will be less, magnitude of attraction is more. Because a double bond, 4 electrons. Due to higher attraction, atoms are much closer. Here atoms are somewhat far away. Due to far away, this distance between them is high, distance between them is low. Therefore, between these two nuclei, distance is less. Between these two nuclei, distance is high. Therefore, this bond length is high, this bond length is low, we can say. Therefore, single bond will have higher bond length, double bond will have lower bond length. Like this, we can say. Sir, single bond means bond length will be high, double bond means bond length will be low. That's what we have discussed. Suppose if triple bond is there, how bond length will be there? Still less will be there. Sir. Now, the experiment says that the bond length is 128 picometer. Compare this value with this 148. This experiment says that bond length is lesser than this 148. Lesser in the sense, here single bond not possible, greater than single bond possible. That's what this experiment says. Say single bond means 148. Here experiment says that bond length is 128. That indicates this is not single bond. It is greater than single bond because this length is less than this. Sir, we'll compare with this left side double bond. Here 121, but experiment says that 128. This experimental bond length is greater than that of this one. That means here double bond will not be there, less than double bond will be there. Less than double bond will be there here. Here we said greater than single bond. Here we are saying less than double bond. So this experiment says that bond in ozone is greater than single bond but less than double bond, like this is there. Sir, then this structure, this Lewis dot structure is not explaining this experimental fact. Therefore this Lewis structure, this Lewis dot structure is not actual structure of ozone. Okay, it is not actual structure of ozone. This is what is this structure? In the sense, this is one possibility of writing structure of ozone. This is one possibility. The structure of ozone may be like this, as per Lewis. Okay, sir, as per Lewis we propose to this structure, but this is not in accordance with experiment. Therefore it is not actual structure of ozone. Sir, we will see other possibility. We'll see. Now we have written in this one double bond on left side, we have written dative bond on right side, we have written. Let us interchange and we will see. This is a dative bond on left side, double bond on right side, like this we will write and see what will happen, whether we are getting actual structure or not, we'll see. So oxygen, here this side left side dative bond, right side double bond. Formal charges will give, okay, here +1, here -1, like this we have written. So now we have written this ozone structure we have written. This is nothing but what? Just a reverse of this. That's all. This is nothing but just a reverse of this. Then how can it explain experimental fact? This structure is not explaining experimental fact. This structure is not explaining experimental fact. Therefore this is not actual structure of ozone, sir. Then we will do one thing. For this ozone, as per Lewis, is there any possibility of structure? We'll see. For this ozone, as per Lewis dot structure, we have written the possible structures we have written. Is there any more possibility? No more possibility, sir. So what is the actual structure? That we will see. Actual structure of ozone, how it will be there, that we will see. Here 3 oxygen atoms present in a bend shape. Here also 3 oxygen atoms present in a bend shape. So in the actual structure also 3 oxygen atoms may be present in bend shape. We will take and we will try. Okay, here lone pair will write. This central oxygen atom is having one lone pair. This central oxygen atom is having one lone pair, that we have written. This central oxygen atom is having +1. Here central oxygen atom is having +1. Therefore we will write +1. From the possible structures, these are possible structures of ozone. From the possible structures of ozone, let us try for a actual structure of ozone. Okay, sir. So here central atom is having +1. Here also central atom is having +1. So we will write +1 here. Here left side is a double bond, that means sigma bond is there. Here left side is having sigma bond, so we will write sigma bond on left side. Here right side is single bond, that means sigma bond is there. Here right side double bond is there. Double bond means certainly one sigma bond will be there. So we will write sigma bond on right side. Set. Here left side is having pi bond. Double bond means pi bond is there. Left side is having pi bond, double bond. Here left side double bond is there, that means pi bond is there. Here right side double bond is there, that means pi bond is there. Here left side pi bond, here right side pi bond. Let us do one thing here. We will divide pi bond equally to left side as well as right side. Okay, so here in this possible structure of ozone, left side is having double bond, pi bond. In this possible structure of ozone, right side is having double bond, pi bond. Now in the actual structure, we are trying for actual structure of ozone. Let us do one thing. This pi bond we will distribute in left side as well as right side to equal extent. So equal extent in the sense here half pi bond we will give, Here half pi bond will give. Okay. Therefore, here what is the bond means 1 sigma bond of pi bond. Here what is the bond means 1 sigma bond of pi bond. Therefore, here 1.5 bond is there. Here also 1.5 bond is there. 1.5 bond in the sense 1 sigma bond of pi bond, like that meaning. Sir, here right side oxygen is having -1 charge. Here left side oxygen is having -1 charge. In this possible structure of ozone, right side oxygen is having -1 charge. In this possible structure of ozone, left side oxygen is having -1 charge. We are trying for actual structure of ozone. No, in that shall we do this -1 charge, we will distribute equally to left side oxygen as well as right side oxygen. We will distribute equally. So here -1/2, here -1/2. We have distributed -1 equally to left side as well as right side oxygens. Then each oxygen will get -1/2. Left side oxygen gets -1/2. Right side oxygen gets -1/2. Like this we have written. Now we will see the experimental result, and this we have tried for actual structure of ozone. No, from this we have tried for actual structure of ozone. Whether it is actual structure of ozone or not, that we will see from experimental fact. Okay. Experiment says that bond length in ozone is 128 picometer. That is only one value possible. Only one value possible. That is experimental fact. Sir, now we will see here left side 1 sigma bond of pi bond. That means 1.5 bond. Right side 1 sigma bond of pi bond. That means 1.5 bond. Right side 1.5 bond is there. Left side also 1.5 bond is there. That means left side and right side bond nature is same. Nature of bond in left side, nature of bond in right side remains same. Therefore, this ozone is having only one bond length. Experiment says that ozone is having only one bond length. That's what this structure also says. Sir, then this bond is 1.5 bond in the sense this bond is greater than this single bond. It is 1.5 bond means lesser than this double bond. Correct? So 1.5 bond means it is greater than this single bond. That means this bond length is less than this 148. And this bond here bond is 1.5 bond, here double bond means 121. 1.5 bond means here bond length is greater than 121. So this bond length is greater than 121 and this bond length is lesser than 148. The experiment says 128, in between 121 and 148. Therefore, this structure is explaining the experimental fact. Therefore, we can say it is actual structure of ozone. Whereas these two structures are not in accordance with the experimental fact. Therefore, these two structures are not actual structures. These two structures are not actual structures. These two are not actual structures. It is actual structure. Okay. So, but we have written this actual structure with the help of these structures. This structure has given some contribution for writing actual structure. This structure also has given some contribution for writing this actual structure. Therefore, we can say these structures are contributing structures. These two structures are called contributing structures for writing this actual structure. That means this actual structure is in between these two structures. How do we say? Left side double bond, left side 1.5 bond. Left side single bond, left side 1.5 bond. 1.5 bond will be in between double bond and single bond. Similarly, right side single bond, here right side 1.5 bond, here right side double bond. That means This bond is, this right side bond is in between this right side bond and this right side bond. That means it is nothing but what, in the sense, these two, it is nothing but it is obtained from these two. Therefore we can call this as a hybrid. This as hybrid structure, we can say. Sir, so here we have written for ozone Lewis dot structure. We have written this one, another possibility of this. Therefore these two structures are alternating structures. These two structures are alternating structures, we can say. So these two structures are contributing structures, alternating structures. Another name is called canonical forms. Canonical forms. So for ozone we have written contributing structures, alternating structures, canonical forms we have written. From contributing structures we have written a hybrid. This hybrid is the actual structure of the molecule. So next we will see. Now this is a ozone Lewis dot structure. This ozone Lewis dot structure, we can this ozone Lewis dot structure will change from year to year. How you see that? Now I have written this ozone. Next I will write, see, this bond I will shift here, this bond and this bond I will shift here, and this bond I will shift to this place. Then I will get like this. So that means we can get this structure from this by shifting electron pairs. By shifting electron pairs, we can write this structure from this. Correct? So we can say that interconversion by short electron shift, we can say. That means this electron cloud comes to this place, this electron cloud goes to this place, means we will get this. Correct? If this electron cloud comes here and if this electron cloud goes here, we will get back this. That means these two are interconverted. These two are interconverted. That means these two also interconverted. These two also interconverted. Therefore double-headed arrow mark. These two are interconverted. Okay. Interconversion by short electron shifts results what structures? Means resonance structures. Sir, so what is resonance structures? That we'll see. Resonance structures can be interconverted. Resonance structures can be interconverted by short electron shifts. So we can say these two are resonance structures. From these two resonance structures we got this hybrid. Therefore it is called a resonance hybrid. This resonance hybrid is equivalent to resonance structures, because from resonance structures only we have written resonance hybrid. This resonance hybrid is called a actual structure of a molecule. This is explaining experimental fact. Resonance structures are not explaining experimental fact. Therefore resonance structures are false structures. Resonance hybrid is a true structure. So next we'll see resonance structures for other species. For ozone we have written resonance structures, and then we have written resonance hybrid. This phenomenon is called resonance. Now resonance is the topic from valence bond theory. In valence bond theory, one topic is what means pure orbital overlapping concept that explains some of the molecules shapes. Then hybridization. Hybridization is introduced in valence bond theory that explained some of the covalent molecules shapes, bond length, bond angle. Then resonance also introduced in valence bond theory. It explains some of the molecules shape, bond length, bond angle, like this. Now in the resonance continuation we will take some more molecules. We will write the possible resonance structures and resonance hybrid we will write. Okay. Now we will take a perchlorate. We will take. We are writing perchlorate. Perchlorate formula is ClO4 minus. Now chlorine we will take. This chlorine belongs to 7th A group. Therefore, this valence shell is having 7 electrons. Those 7 electrons will write. Now 4 oxygen atoms. 4 oxygen atoms we have written. For one oxygen atom you give -1. The oxygen which is having -1, that will make only one bond. Then oxygen atom will make double bond, otherwise 2 single bonds. Okay, so this is called perchlorate. For it is this is called what in the sense resonance structure for perchlorate. What is other possible resonance structures that we'll see? This single bond we will give in this place. This single bond we will give in this place. It is called another possible resonance structure. Another possible resonance structure. Okay. Next possible resonance structure we'll write. This single bond we will write here. This single bond we will write here. This is a next possible resonance structure. Sir, next possible resonance structure will write this single bond we will write here. Okay, we have written here. This single bond we have written here. So we have written the possible resonance structures for a perchlorate we have written. Then we will go for resonance hybrid. We are going for resonance hybrid. For resonance hybrid, we will write central atom Cl and the surrounding atoms, 4 oxygen atoms we will write. 4 oxygen atoms we have written. Now see here, in all the resonance structures, these are resonance structures. In all the resonance structures, between Cl and oxygen, sigma bonds are there. In all the resonance structures, between Cl and oxygen, sigma bonds are there. Therefore, we will write sigma bonds between all the Cl and oxygen atoms. Then here 3 pi bonds are there, here no pi bond. Here 3 pi bonds are there, here no pi bond. Here 3 pi bonds are there, here no pi bond. Here 3 pi bonds are there, here no pi bond. So what we will do means we will distribute all the 3 pi bonds equally into all the places. Distribute all the 3 pi bonds equally into all the 3 places. Okay, so we are distributing all the 3 pi bonds equally into all the places. So here in the 3 pi bonds, 1/4 part is distributed here. In the 3 pi bonds, 1/4 part is distributed here. 1/4 part of 3 pi bonds distributed here. 1/4 part of 3 pi bonds distributed here. That means here one sigma bond is there. In all the places, one sigma bond is there. In all the places, how much pi bond is there? Means 3/4 pi bond is there. Here 3/4 pi bond. Here 3/4 pi bond. Here. In all the places, what is the bond in the sense? One sigma bond and 3/4 pi bond. That means nature of bond is same in all the places. Nature of bond is same in all the places. What is the evidence? Experimental evidence says that in perchlorate, bond length value is only one. Only one bond length value possible for perchlorate. That is explained by this structure. Correct? Because in all the places, bond is remaining same. One sigma bond and 3/4 pi bond is there. Then regarding this negative charge also you'll see this oxygen is having -1 charge. Here this rightmost oxygen is having -1 charge. This rear side oxygen is having -1 charge. This left side oxygen is having -1 charge. Now we will do one thing, that -1 charge we will distribute equally into all the 4 oxygen atoms. Here -1/4, here -1/4, here -1/4, here also -1/4. So -1 charge we have distributed equally into all the 4 oxygen atoms. Now you see the perchlorate. Experimental fact says that in perchlorate, nature of bond, experimental fact says that in perchlorate is having only one bond length value. That is explained by this experimental, this resonance hybrid or not. Therefore, it is the actual structure of perchlorate. These are resonance structures of perchlorate. Okay, sir. We have written resonance structures of perchlorate. We have written. Then we will take a chlorate. Will take, for chlorate we will write resonance structures. Okay, so I will take chlorine and 3 oxygen atoms. I will write 3 oxygen atoms, minus 1 I will give to any one of the oxygen atom for resonance structure. Then for this chlorine, the valence shell contains 7 electrons, so we will give 7 dots. We will give 7 dots we have given. Now this oxygen will make double bond, otherwise 2 single bonds. This oxygen makes double bond, this O minus will make single bond. O minus will make single bond. This is what in the sense per this is chlorate. Okay, next possible resonance structures we will see. Next possible resonance structure is so and so. Next possible resonance structure is so and so. We will write the next possible resonance structures of chlorate. We are written like this. Next we will write resonance hybrid. Resonance hybrid in the sense in all the places we will give sigma bond. We will give, sir, these two pi bonds we will distribute equally into all the three oxygen atoms. Here 1/3 of 2 pi bonds, 1/3 of 2 pi bonds, 1/3 of 2 pi bonds. That means here 1 sigma bond and 2 by 3 pi bond. Here 1 sigma bond, 2 by 3 pi bond. Here also 1 sigma bond and 2 by 3 pi bond. Then this minus 1 charge will distribute equally into all the three oxygen atoms. So here minus 1 by 3, minus 1 by 3, minus 1 by 3. Now all the bonds have same nature. This resonance hybrid says all the bonds have same nature. So as per resonance hybrid, this chlorate will have only one bond length. Even experiment also says same. Sir, therefore this experimental fact is explained by this resonance concept. Sir, okay. Now in perchlorate, how many resonance structures are there? You count it. In perchlorate, how many resonance structures are there? See, 1, 2, 3, then 4. In perchlorate, 4 resonance structures are there. So number of resonance structures for perchlorate is 4. Number of resonance structures for chlorate is 3. Number of resonance structures. Here this resonance structures we are getting in the sense, how we are getting in the sense, this double bond is shifting here, this single bond is shifting here, so that we got here. We are getting this one from here. How means this double bond shift here, single bond shift here. Therefore electron cloud is shifting from one place to another place, means due to attraction only that is shifting. Now due to attraction means that is giving stability. More number of resonance structures in the sense, more times electron cloud shift is possible. More time electron cloud shift is possible means more attraction. That's why, therefore this stability will be more, whereas this stability will be less. Therefore stability of the molecule depends on what? In the sense resonance structure. If the number of resonance structures high, then stability will be high, we can say. If number of resonance structures high, then we can say stability will be high. Okay, so we can say number of resonance structures high in the sense stability will be high, we can say. Set in this way we can write resonance structures. We can write. Next we will take nitrate. For nitrate we will write resonance structures. So nitrogen, 3 oxygen atoms, we will write 3 oxygen atoms. This minus 1 will give. Nitrogen valence shell is having 5 electrons, therefore that 5 electrons we will write as 5 dots. 5 dots we have written. Now we will write bonds. We will write O minus will make single bond. Oxygen atom will make double bond or 2 single bonds. Nitrogen, remember that nitrogen can form 3 normal covalent bonds and 1 dative bond. That's what nitrogen can form. Okay, nitrogen can form 3 normal covalent bonds and 1 dative bond. Nitrogen maximum covalence is 4. It can make maximum 4 bonds. More than that it cannot. Sir, so we have written what in the sense nitrate we have written. It is one resonance structure. We will go for another possible resonance structure. We'll write double bond in left side. We'll write double bond on top. Okay, dative bond and negative charge we have given. Then next resonance structure we'll write for nitrate, N oxygen atoms. Now double bond will bring to right side, and negative charge here, dative bond here. Okay, these are the possible resonance structures of nitrate. So for nitrate we have written the possible resonance structures we have written. Now we will go for resonance hybrid. Now we will go for resonance hybrid. Nitrogen, 3 oxygen atoms we will write. Now this dative bond, I will write it as a formal, I will write it as a normal colon 1 by giving formal charges. Okay, this dative bond, I will write as a normal colon 1 by giving formal charges. So plus 1 here, minus 1 here. It is a donor, therefore plus 1. It is acceptor, therefore minus 1. Okay, dative bond we have written as a normal colon 1. Okay. So this dative bond, I will write it as a normal colon 1 by giving formal charges. Okay, here plus 1, here minus 1. Then we'll write this dative bond also normal colon 1 by giving formal charges, here minus 1, here plus 1. Now we will go for resonance hybrid. In the central atom, nitrogen is having plus 1 in all the cases, therefore we will give plus 1. The central atom nitrogen is making sigma bond with all the oxygen atoms. The central atom nitrogen is making a sigma bonds with all the oxygen atoms. So we'll write sigma bonds. Then one pi bond is there. This pi bond let us distribute equally into all the 3 oxygen atoms. So we are distributing pi bond. Let us give how much pi bond in the sense 1/3 of 1 pi bond. That means 1/3 pi bond will distribute here. 1/3 pi bond we have distributed. Then here how much minus charge is that? Totally means minus 2 is there. That minus 2 we will distribute equally into all the 3 oxygen atoms. Therefore here minus 2/3, here minus 2/3, here minus 2/3. So minus 2 charge we have distributed equally into all the 3 oxygen atoms we have distributed. Okay. If nitrogen is having plus 1, then we have to distribute minus 2/3 to each oxygen. If you do not write plus 1 for nitrogen, then you have to give minus 1/3 to each oxygen you have to give. Okay, this is a resonance hybrid. This is actual structure. Now you say, shall we say it is trigonal planar? It is having only one bond length. Bond angle is 120 degree everywhere. Okay, this nitrate bond angle is 120 degree. It is having only one bond length. It is a perfect trigonal planar. This is experimental fact. That experimental fact is explained by resonance. Even hybridization and pure orbital overlapping concept is not explained. So resonance is explaining. Okay, even resonance also coming under valence bond theory only. In the valence bond theory, resonance concept is introduced. So we have seen regarding this. Next we will see about, we will take benzene, we will take, for that we will write resonance structures, we will write benzene. Benzene is a organic molecule. This organic compound formula is C6H6. Here the experimental evidence says that all the carbon atoms and hydrogen atoms are in a plane. All the carbon atoms and hydrogen atoms are in a plane. That is experiment says. Experiment says all the carbon atoms and all the hydrogen atoms in benzene molecule present in one plane. Sir, as per that we will write. So 6 carbon atoms are there. That 6 carbon atoms we will write like a cycle. Cyclic chain. It is cyclic compound. It is a benzene is a cyclic compound. We have, so that we have written all the 6 carbon atoms in a cycle. Then 6 hydrogen atoms are there. Now we will give to each carbon 1 hydrogen. Let us give 1 hydrogen to each carbon. Okay, we have given 1 hydrogen to each carbon. Sir, now carbon